Hello, today I'm going to show you how to get the COT data and to plot the COT data, the relevant data of the COT report. And we use the package COT reports to get the data. And we get historical price data with Y Finance. And you just have to define a ticker and a start year. The earlier the start year, the longer it takes to calculate, because the COT report package only allows to download the COT data for an individual year, and we have to concat the data frames. So the download process takes a bit of time, and the earlier the year, the more downloads have to take place, and the slower the script proceeds. So it's faster if the year is higher. The end year we get with the date time, and we use the current year, and we need to create a list for the loop, and we create a list with the range function, and use the start year as beginning and the end year plus 1 as the end and as the limiter. And so we have a years list. We also need to create empty data frame for concatenation. This is the COT underline DF, I called it here. And for plotting, I am just interested in the net positions of the commercials and the net positions of the non-commercials. So if you are interested in other columns or other values, you can extend it as you wish. But for this example, we just leave it at here. And this dictionary got created because it's much easier to connect the names in the COT reports to get data with the ticker. So you just have to change the ticker if you want to see another asset, and it automatically changes the name for the COT data search. And yeah, these are the tickers which are of interest to me. Of course, there are more, but for me, this is enough for now. We need to transform the start date to string and the end date, and then we can download the financial data. This is not the COT data. With Y Finance, we download the financial data from start date to end date. And we set the index as date time, and I am just interested in the adjusted close column, so that's why I reduce the data frame to the adjusted close column. You could also use the volume data probably, or the open, or the high and the low if you want to have it more complicated, but the close data is enough for me. Then there's a loop, and we loop through every year in years. And then we get the COT data per year, and the year increases with every loop iteration. So for now, in the first iteration, we get the data for 2015, the legacy futures data, and the name for the asset which is of interest. We get the name by giving the ticker as a key to the ticker name dictionary, and so we get the name as a value, and we can save it under name. This makes things easier and more efficient. We filter the data frame because the data frame, if you get it, it's a mess, so you need to filter it. In the beginning, for the relevant columns, here are a bit more columns than we actually need, but like market and exchange names, we need this. The dates we need, and the commercial positions long, commercial positions short, and the non-commercial positions long and short. And here we get only the relevant rows which have the name of the instrument in the column. So here we select for the asset of interest. In this case, it is silver. So the name is Silver Commodity Exchange Inc. And we use this name to select only the data for silver. And the columns, they are named quite complicated, like as of date and form YYY. So it's a very long name. That's why I rename it to make things easier. I just rename it to date, commercial positions long to com long, the short positions to com short, and non-commercials long, non-commercials short. So just to have a nice name to work with. Yeah, we have the date column. We transform it to date time for easier plotting and handling, and we set it as index. To calculate the net positions, we just subtract the commercial short positions from the commercial long positions, and do the same for the non-commercial positions to get the net position. And I just want those two columns. That's where I reduce the data frame to those two columns. And then we concat for every year. We concat it to the previously empty data frame COT DF. So every year you have the filtered COT DF futures, which gets concatenated to the COT DF vertically with the axis equal to 0. And at the end, we have the COT data for all of the years saved in the COT underline DF, and then we concatenate it with the previously downloaded Y-Finance data. And this time we concatenate it horizontally with the axis equal to 1. And then we have the data frame with the Yahoo Finance historical price data and the COT data with the net positions of the commercials and the non-commercials. And to avoid errors, we need to transform everything to numeric, because there are some hidden values which are not numeric somehow, and they need to be converted to numeric. And for the plotting, we also do a forward fill for the COT data, so we can get a nice black line. And next step is the plotting. So we initialize a figure with axis. In this case, we have 3 rows, 1 column. They share the x-axis, and the fixed size is defined here. And yeah, we plot the DF index is always the date time data. We plot it against the adjusted close with a black line, and set the title. Here again, we just use the ticker as the key for the dictionary, and then we get the name, and this is our title. Yeah, and we set the grid as true just to see it more easily, which year has which value and so on. We do the same for the second axis. And here, one thing that we add here is we want to have a green area where it's above 0, and the red area where it's below 0. So we do this with the fill between method. And yeah, we have some transparency here with 0.3. and we also set the title and make a grid, and we do the same for the third axis, which are the non-commercials. And yeah, we rotate the x ticks on the third axis by 90 degrees, just so you can read it more easily. Then it looks like this, and it doesn't overlap. Yeah, this is now the silver commodity exchange data, and what you can see is that the commercials, this is a good indicator in my opinion. If the commercials are net long, you might expect a bottom, for example, like it happened here or here or here. So these are quite important bottoms. Or you can also see if the price maybe is overextended if you have a very strong short position here. Okay. Yeah, this is it. So if you download it for 2015, you would have to wait a bit because it needs to download, in this case, 9 years, but let's do it with example 2022. So we only have to download 3 years. So this is the download of the Y Finance data. And here it's downloading the 2022 data from the COT report package, the 2023 data, 2024 data. And so you have it in a higher resolution. So this is quite useful for analyzing the futures and commodity market.